All right, now we start the work of polynomial functions. Remember, up to now, if you have y is equal to a number, it's a horizontal line at the height of that number. If you have y is equal to x, well, whatever you put in for x, that will be y. So it's a graph that parent graph looks like this. And then we also have done y is equal to x squared parabola. Well, now we're going to start dealing with the higher exponents. All right, so here's some parent graphs. If you have y is equal x to the odd, well, think about that. Y is equal to x, that's x to the first. Well, what is that graph? Well, where x is 1, y will be 1. Where x is 2, y will be 2. And so forth. -1, -1. And you've got a graph 0, 0. So that's x to the first power. So y is equal x to the third power. See what these endpoints are doing? They're going the opposite direction. When the exponent is odd, the graph endpoints will be headed in opposite directions. So notice, this is an odd exponent, and those endpoints are headed in opposite direction. So the other thing you have to know, whatever this highest exponent is, if you subtract 1, that's the number of turns that you will have on the graph. So 3 subtract 1 is 2. Look what we have, 2 turns. 1 subtract 1 is 0, and notice that straight line, there are 0 turns. Okay, so sometimes you'll have to notice, and then finally, you'll have to notice the intervals of increasing and decreasing. Well, for x to the first, all of those x values, that entire graph as you read left to right is going up. So for intervals of increasing, it's from negative, all the x's from negative infinity to positive infinity. That entire graph is increasing. But let's look at this one. Well, from here to here, we'll call that point A. We'll call this point B. So from negative infinity up, oops. Make that a little bit bigger. For intervals of increasing from negative infinity up to A, that graph is increasing. And then from A to B, the graph is decreasing. And then from B, whoops, I should have done that in yellow. And all of those x's right there, that graph is going to continue to go up. So from B to positive infinity, we're back to increasing again. All right, so I'm going to clear all this out. What do we determine so far? That if it's x to the odd, the endpoints will be going in opposite directions. When it's x to the even, so like x squared, the endpoints are going in the same direction. So if you had x to the, a negative x to the even, it would be turned upside down, but look at the endpoints are going in the same direction. All right, let's get started on an example. So for this function right here, there is no number being added, so we're going to put 0. We already know that it'll touch right there. And we know that it's an x cubed, so that's an odd exponent. So we know the endpoints will be going in opposite directions. And that lead exponent, 3 subtract 2, 3 subtract 1, there will be 2 turns. Now, I don't know exactly what it could look like, but it could look something like this. And if you want to be more precise, then, and if I want you to be more precise, pick 1 or 2 points so we know it touches at 0. And the y value is also 0. All right? So I would plug in maybe 1 and 3 and -1, -3. So if we plug 1 in there, 1 cubed is 1 minus 3 times 1 squared is 1. 1 subtract 3 is -2. All right? Now let's put 3 in there. 3 cubed is 27. And then minus 3 times 3 squared. Well, 3 squared is 9. So that's 27. So that's going to be 0. So this was -2. So this graph so far is doing this. That looks about right. Now let's put in -1. Well, -1 cubed is -1. Subtract 3 times -1 squared. Well, -1 squared is 1. 1 times 3 is 3. -1 subtract 3 is -4. So at -1, we're down here. Oh, look it. That's all the information we need to know. We plugged in, we already had 0, 0. We plugged in 3 numbers, and we get a plausible graph for that. And now you could look at the intervals. So let me do this in red. Where x is 0, there's that curve. Where x is 1, there's a curve. So for the intervals of increasing, all of these x's here, when you put in any of these x's, you're going to get a y that's headed down that way. So for intervals of increasing, decreasing, from -infinity up to 0, increasing, and then now look at what we have. We have this interval between the x's 0 and 1. We have it's going down, it's decreasing, and then all of these x's here, if you put in +8, you're going to get a value up there somewhere. So from the interval 1 to +infinity, we're increasing. All right? And it asks the number of terms. Well, the turns. Well, that's an x cubed, and to find the number of terms, you just turns. I keep saying terms. 3 subtract 1 will be 2 turns. And look at 1 turn, 2 turns. And you have to list where it does not cross the x-axis. Well, let me erase this so that you can see. Remember, there was a turn, so it did not cross. So where x is equal 0, it didn't cross the x-axis. And where x is equal, let's see, so see that? Where x is equal to 3, there's a 0. Where x is equal to 3, remember, it crossed there. It did something like that. It crosses. State the intervals of increasing and decreasing. And normally you have to tell me the domain. Remember what I said for all polynomials? The domain is -infinity, +infinity. And for all x to the odds, the range is also -infinity to +infinity. So if this is y is equal to x, both of those are because that's x to the first. If you have x cubed, x to the fifth, x to the 101st, the domain and range will both be -infinity to +infinity. All right, that's it for this one.